On the distant world of Kepler-22b, there is a rainforest unlike any found on Earth. From above, Verdantia appears lush and alive. Vast emerald canopies ripple beneath drifting mist. Rivers carve silver paths through endless green, and towering alien trees stretch toward a pale, unfamiliar sun. But as the camera descends, another truth reveals itself. The forest does not grow from soil alone. Embedded within roots, trunks, cliffs, and riverbeds are crystals, thousands upon thousands of them. Some glow softly in emerald hues, others shimmer blue, gold, violet, or white. They are not scattered randomly like stones. They grow in patterns, networks, living constellations rooted in the forest itself. These are the Crystal Foragers. They are not animals. They do not move. They do not hunt. They grow. And without them, Verdantia would not survive. Verdantia's rainforest exists in a state of constant transformation. Heavy rains fall daily, fed by thick cloud layers and powerful atmospheric circulation. Rivers swell and retreat, soil shifts, nutrients flow endlessly through the ecosystem. On Earth, such conditions would strip a forest bare over time. On Verdantia, they do not. The reason lies beneath the surface. Crystal foragers form the foundation of the rainforest's stability. Growing directly from mineral-rich soil, they bind loose ground together, anchoring roots and riverbanks against erosion. Where rainwater would normally wash nutrients away, crystals absorb and regulate the flow. They are not passive structures, they are active regulators. Verdantia's rainforest stands not despite the crystals, but because of them. At first glance, crystal foragers resemble gemstones, faceted, translucent, and immobile. But closer inspection reveals something extraordinary. Their surfaces are not inert mineral. They pulse faintly. Their internal glow fluctuates with humidity, temperature, and chemical changes in the soil. Under magnification, their structure is neither purely crystalline nor cellular, but something in between. Each crystal forager is a living biomineral organism. Instead of cells built from carbon-based tissues alone, their bodies are formed from layered lattices of mineral compounds interwoven with living microbial matrices. These microscopic life forms guide crystal growth the way DNA guides cell division. The result is a living gemstone capable of growth, repair, and environmental response. Growth begins underground. Beneath Verdantia's rainforest floor lies a vast web of microbial and fungal networks feeding on mineral-rich groundwater and geothermal energy rising from the planet's interior. Within these networks, specialized microbes begin organizing dissolved minerals into ordered structures. Over time, these structures push upward. Crystals do not erupt from the soil. They emerge slowly, millimeter by millimeter, responding to environmental cues. Rainfall accelerates growth. Drought slows it. Chemical imbalances alter color and density. Time-lapse imagery reveals an astonishing sight. Crystals branching, thickening, and reshaping themselves in response to their surroundings. Verdantia does not simply have crystals, it cultivates them. Crystal foragers did not evolve for beauty, they evolved for balance. Verdantia's soil is saturated with heavy minerals, some of which are toxic to plant and animal life. Left unchecked, these compounds would poison rivers, disrupt plant growth, and collapse the ecosystem. Crystal foragers absorb these minerals. Within their biomineral lattice, harmful elements are neutralized, stored, or transformed into stable compounds. Excess energy, thermal, chemical, and electromagnetic, is buffered and redistributed gradually. In essence, crystal foragers act as environmental filters, regulating the rainforest's chemistry in real time. They are the forest's kidneys, its liver, its immune system. Not all crystal foragers are the same. Their colors are not cosmetic, they are functional. Green crystals grow near plant roots, releasing trace nutrients that accelerate photosynthesis and regeneration. Blue crystals dominate riverbanks and submerged root systems, stabilizing water chemistry and filtering contaminants. Amber crystals cluster in sunlit clearings, storing thermal energy during the day and releasing it slowly at night. Violet crystals form near natural electromagnetic anomalies, regulating atmospheric charge and preventing violent electrical discharges during storms. Each color represents a different ecological role. Together, they form a planetary system of checks and balances, silent, glowing, and alive. The rainforest's animals have evolved alongside the crystal foragers. Some herbivorous species graze on mineral-rich moss that grows only near crystal clusters. Others lick crystal surfaces to supplement trace elements absent from plant matter. Larger creatures rest near crystal groves, where temperature and electromagnetic stability reduce stress and disease. Predators, too, benefit indirectly. Healthier prey populations lead to sustainable hunting cycles. In Verdantia's rainforest, survival is not about domination. It is about harmony. Crystal foragers do not stop at the forest floor. Along riverbeds, flooded roots, and submerged cave systems, underwater crystal colonies glow softly through the current. These aquatic crystal foragers filter dissolved toxins, clarify water, and stabilize river temperatures. Fish-like alien species gather near them, drawn by increased oxygen levels and nutrient-rich microecosystems. Algae blooms flourish in controlled balance, supporting entire underwater food webs. Where crystals grow, water becomes life-supporting rather than destructive. Seen from above, patterns emerge. Crystal clusters form networks that mirror the branching of rivers and roots. Energy pulses ripple slowly across the forest floor, synchronized with rainfall cycles and planetary rotation. Verdantia's rainforest is not merely an ecosystem. It behaves like a single, distributed organism, one whose organs are made of living stone. The crystal foragers are its connective tissue. When humanity first begins studying Verdantia, sensors struggle to interpret what they see. Mineral scans suggest geological formations. Biological scans suggest microbial colonies. Neither tells the full story. Only long-term observation reveals the truth. The crystals grow intentionally, respond dynamically, and repair themselves when damaged. To study them, scientists build floating research platforms above the canopy and sealed laboratories within stable clearings. For the first time, living gemstones are brought under direct observation. Inside the lab, holographic projections fill the air. Scientists rotate three-dimensional models of crystal foragers, peeling back layers to reveal biomineral cells depositing lattice structures in real time. Energy flow diagrams show how chemical gradients guide growth direction. Simulations replay centuries of development in seconds. The conclusion is unavoidable. These are not rocks colonized by life. They are life that chose to become rock.
Planet-wide holograms map Verdantia's soil composition. Regions with dense crystal forager networks show lower toxicity, higher biodiversity, and long-term stability. Areas without them, often damaged by landslides or experimental interference, degrade rapidly. The crystals are not optional. They are foundational. Remove them and the rainforest collapses.
Scientists attempt replication. In controlled chambers, Verdantian soil is recreated. Minerals are introduced. Microbial cultures are grown. Slowly, imperfect crystals begin to form. But something is missing. Without the full planetary context, the precise gravity, magnetic field, radiation balance, and biological diversity, the lab-grown crystal foragers are fragile. They fracture easily. They fail to self-regulate. Verdantia itself is part of the organism. Simulations reveal a grim future. Without crystal foragers, toxic minerals accumulate, rivers become acidic, root systems fail, landslides increase, animal populations crash. The rainforest does not burn or explode, it simply unravels, slowly, quietly, irreversibly.
Scientists began describing the crystal foragers in new terms. They are not resources. They are not curiosities. They are planetary organs, structures evolved not for individual survival, but for environmental regulation on a global scale. Verdantia does not host life. Verdantia is life. As darkness falls, the rainforest transforms. Bioluminescent plants glow softly. Crystal foragers brighten in response to cooling temperatures. Rivers shimmer like liquid starlight. The forest pulses gently, as if breathing. Animals move carefully through the glow, guided by crystal-lit paths. No sound is wasted. No energy is uncontrolled. The crystal foragers force humanity to confront a profound truth. Life does not have a single blueprint. It does not require leaves or blood or bones. It does not even require softness. Life can be crystalline. It can be slow. It can be planetary. Long after observers depart, Verdantia continues its ancient rhythms. Rain falls, crystals grow, forests thrive, rivers flow clean and stable. Life moves in balance, guided by living stone beneath its feet. The crystal foragers remain where they have always been, rooted, glowing, patient. Somewhere in the universe, other worlds may host similar systems, living reefs of stone, bio-mineral forests, planets that regulate themselves through growth rather than conflict. Verdantia is not an exception. It is a preview. The crystal foragers do not walk, they do not hunt, they do not speak. And yet, without them, nothing on Verdantia could exist. They are proof that life does not always rise from the ground. Sometimes, life is the ground.